Hello friends and welcome back to my YouTube channel. First of all, let me request you to spend your 3 minutes for this particular question. I can assure you that it will be definitely useful for you. So it's actually a question asked from GATE 2019 examination in mathematics stream. So let's move on to the question. A very interesting part in this particular question is that we are given a vector space 3 by 3 matrices with complex entries over the real field. So if you just don't look into this properly, the answer will definitely go wrong. So that is the main key thing here. If you have seen this or noted this in the question, then you know you won't go wrong. Okay. So if you take the case W1 and W2, and if you're asked to find the dimension of W1 plus W2, so we have this relation regarding dimension of subspaces. So here you can see if W1 and W2 are two subspaces of this particular vector space, and we are asked to find what is dimension of W1 plus W2, and we know it's actually equal to dimension of W1 plus dimension of W2 minus dimension of W1 intersection W2. So let's find out dimension of each of these cases and we'll get the answer to this question. If you consider W1, you can see what are the matrices, what kind of matrices we have here. Set of all matrices for which A is equal to A transpose conjugate. So what kind of matrices we'll have in this? So if you have a complex entry A plus bi, then what will you have here? You'll have something like A minus bi here, right? Similarly, if you're going to have C plus di here, then you're going to have C minus di in this position, and E plus fi if you have E minus fi here. And if you look at the diagonal entries, what will be the diagonal entries there? It should be equal to its transpose conjugate, right? So the element here should be actually a real number, so which has to have something like some G, H and I. Okay, so here A, B, C, D, E, F, G, H and I are real numbers. Okay, so this is the kind of matrices we can expect in W1. Now we can easily find the dimension, right? So what is the dimension of this particular space? We have 1, 2, 3, 4, 5, 6, 7, 8 and 9. So we have 9 as a dimension of W1. Now those who have those who have the confusion in how to find this dimension, you can just see in this particular form. So I'll just try to express these matrices as in terms of some linearly independent vectors. Okay, and this is actually will act as a basis. Okay, so we can, this all matrices, complex matrices, we have entries, we have I. Okay, so this matrix will act as a basis. So from this we can just get the basis for this particular space, and we get the dimension as 9. Okay, so this is how we can find the dimension of this particular matrix. So basically when you're finding dimension, you have to find the basis. Basis means it contains the linear independent vectors which can span the complete space. So the minimum number of linear independent vectors which can span the complete space, right? So we got this answer as 9. And what about W2? So W2, again, when you look at W2, W2 is actually the triple matrices which have trace as 0. So you can expect something like this. So if you look at the W2, set of all matrices in W2, they have the property that trace of A is 0, right? So here we have a complex number, maybe A plus bi. Say this we can write as maybe C plus di and E plus fi, complex numbers. So the trace of this is actually equal to 0, and here on we can have other complex numbers. Okay, different complex numbers we can have here, because there is no restriction on those elements. Only restriction is given on the trace. Trace means sum of the diagonal entries. So it's going to be something like that, A plus bi plus C plus di plus E plus fi is going to be 0, or you get A plus C plus E, it's actually 0 plus 0 I, right, is equal to 0, as well as B plus D plus F times I is equal to 0, right? So B plus D plus F has to be equal to 0. From this we can see that if you know A and C, you can predict what is E, and if you know B and D, you can predict what is F. So that means from these positions, from the diagonal entries, you can see that the contribution towards the dimension is nothing but 1, 2, 3 and 4. Okay, plus from these entries there will be 2 constants, right? And from this also we have 2 constants, 2 constants from here, 2 constants from here, 2 constants from here, and 2 constants from here, right? So that means 1 2 3 4 5 and 6 times 2 12. So we have total of 16 with the dimension of W2. So 9 plus 16. See the two constants, what I mean is this will be actually of some form, right? Something like some m plus ni, where we need m and n are the constants, and for this we need 1 1 matrices when we are expressing them in terms of like in terms of the basis elements, just like what we did the previous case when we had W1. I have given a split up, right? So in this form, if you are going to split and write, you are going to use 2 matrices for this particular position, 2 for this position, and so on. So total we have 9 plus 16 here, and minus we need to find dimension of W1 intersection W2. So W1 intersection W2 will have the property that it will have the property of both, right? So the only difference what we are going to have in this W1 intersection W2 is something like this. Sorry, not W1 intersection, sorry, not W1 plus W2, is W1 intersection W2. So what we are going to have is something like matrices of this form. So we are going to have complex entries of this form. Okay, it's transpose conjugates E minus Fi, and again you can see here that is trace of A has to be 0, and this matrix should have a property that A should be equal to A transpose conjugate. So the diagonal entries should be, as I told, should be real numbers. And one more property we must have is something like the trace should be 0. So G plus H plus M should be equal to 0 also. So from this we get that D plus H is equal to minus M. That means we just need to know these two numbers or these two constants. We can predict what is M. So from the diagonal contribution towards the dimension is only 2. That is from G and H. And for the remaining, this portion we need 2, this portion we need 2, this portion we need 2. And that same is enough to decide these portions also. So totally we have 2 plus 2 plus 2 plus 2, that is 2 plus, so we have basically 8. So initially we have found dimension for here it was 9. In this case we found as 16, and the intersection we are getting as 8. So when you find the answer to this particular problem, you're going to get as 17. So this is how you get the answer of this particular question as 17. So thank you for watching this video, and please refer the same playlist for the other set of questions which were asked in these examinations of GATE and CSIR, etc. So if you have any queries regarding this question, you can please comment down in the comment section. I would give an brief, extra explanation for that also. Okay, so thank you so much. See you in the next video.